The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. Observe It enables security teams to detect risky user activity, investigate incidents in minutes, and effectively respond. Get your free trial at observeit.com/securityweekly. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW. Security teams need network data to threat hunt and resolve incidents, but find that PCAP is often too much data and NetFlow isn't enough. Corelight was founded by the creators of Zeek, formerly Bro, and its sensors provide just the right amount of data, transforming raw traffic into comprehensive logs, extracted files, and custom insights so analysts can make fast sense of traffic and move at the speed of attack. To find out why Corelight is your best next move in security, visit securityweekly.com/Corelight. Welcome, everyone. We're at Black Hat in 2019. I get the year right. That's good. That's good. We've been to Black Hat in many conferences and have done these interviews. This is the first time we've got like some major recording going on, lots of interviews to do, all of which I'm very excited about, especially Coresecurity. Steve, how do you say your last name, Steve?
Laubenstein.
Steve Laubenstein. He's the VP of Cyber Threat Products Group at Coresecurity. Now, Coresecurity has, of course, merged or been acquired by Help Systems, but you're maintaining the Coresecurity brand. Yes. Coresecurity goes way back to the very beginning of Security Weekly. Myself and several of the other hosts were using Core Impact in a lot of penetration tests and communicating what we loved about it, which was a lot, actually, to our audience. And so it's nice to come full circle and have you back today and talk about the things that are happening at Coresecurity.
Well, it's wonderful to be here and actually to meet you. I've heard about you over the years through the company.
Yeah, awesome.
First time we've actually had a chance to sit down and chat.
Yeah, it's great. So now Coresecurity today still does penetration testing as a service. You still have the Core Impact product, the penetration testing product. You also do some advanced threat detection, which was added in, which I like. I think it's a nice complement to understanding the latest threats and, of course, probably applying those to your testing, right?
Yes. The product that you're referring to there is a product called Network Insight.
Yep.
And what it does is it identifies devices that have been compromised with certainty. And we're doing this through a variety of ways, but basically we're taking multiple pieces of evidence and able to convict a device that it's been compromised.
So you're automating the threat hunt, essentially, with that product.
Yes, in some senses.
I like it.
We do a lot on the carrier backbones, and to your point of how this all comes together, a lot of the threat research and information we're getting off the carrier backbones from our enterprise customers on that side is coming together with our exploit teams and our people who do the pen testing and really helping build stuff that's more adversarial specific and things of that nature.
So what's the primary problem you're solving today when you go to a customer? Like, what problems are they bringing to you?
Yeah, it's all about risk. I mean, it's like there's not a new, unique problem to go solve per se in this area. It's really trying to identify, quantify, and prioritize what do we need to work on.
Yeah, it's like a picture of their security posture, basically, with the risk equation thrown in there.
Exactly. Exactly. And as we were chatting earlier, you have some pen testing in your background.
Yep. Absolutely.
It's one of the few ways you can definitively define, is this risk or not? Theoretically, it might look like it is on paper, but until you actually go test and find out, it's hard to know. And just like any pro football team, you put them on a field, they look great on paper until they actually go play games.
Yes.
Then you find the weaknesses. And that's what pen testing's about.
That human component is still very, very important, because we can automate as much as we want, but until you put a human and say, test my defenses, I don't think you've really truly tested your defenses. And the difference between an attacker and a pen tester is, with a pen tester you get the results. An attacker is not going to give you, their findings.
Exactly.
Right? So.
And I really like the fact you use the word human. So many people think, oh, hey, you just run this tool and it's going to come back and it's going to spit out all this stuff for you. That's not true. It's a tool to be used by pen testers.
Right.
That'll make them a lot more efficient and provide them a lot more capabilities. but it still needs that human interaction.
Yeah, and there's so much automation and technology today in cybersecurity, right? But what I come down to in my career, I've been at organizations as the defender, and the organization will say, I'll say, like, this piece is vulnerable, and I think it needs to be addressed. And, oh, no one can do anything with that. That's not a risk, right? And we accept that risk when they really don't know what the risk is until a human comes along, uses that vulnerability or exposure in their attack, and see where it leads, that the organization can come back and truly assess risk.
Yeah.
So I think it's very important today to have that.
Yeah, absolutely.
How does it integrate with vulnerability management? How do you see pen testing today integrating with vulnerability management programs?
Vuln programs, obviously kick out thousands upon thousands of vulnerabilities, and the manufacturers are getting good at trying to prioritize from a risk perspective, et cetera. Hey, we think this is most critical, et cetera. What the real missing element in many of these programs is what compensating controls are actually in place.
Yep.
I might have a vuln that's really super critical, but if it's on a server and I got to get hands on a keyboard and that's behind a retina scanner and there's two guys in that room, is that really that critical?
Right.
And there's others that may not be as critical, but they really expose, and provide access and provide a pivot point to get to much valuable.
It's that chaining. I don't believe today we have the software that can make those decisions about if I take this exposure here, that exposure there, and maybe even not even a vulnerability, but some other configuration that you're not accounting for. Individually, you may look at those as the IT administrator or CISO and go, not a big deal.
Right.
When the pen tester comes along and you start chaining those things together, now you have a much better picture of risk, essentially.
Yeah, exactly. I mean, there's a very famous breach, a few years back through a heating and air conditioning computer system.
Right.
Probably not the highest priority from an IT perspective, but we all know what happened there.
Right.
The other key thing with the VM programs, too, is that it really helps you understand the compensating control really effective.
Yes.
We had a customer.
That's a great point.
We had a customer that had applied the latest patch. The vuln scanner came back, said latest patch is there, and they actually had that compromised a few weeks later. Fortunately, it was by a pen tester, and not an external adversary. But what had happened was the guy never rebooted the server.
It's so common. You either didn't reboot, or there's two copies of the DLL on the Windows system. And the vuln scanner goes, yep, you're good, you're patched, but there's another copy of the vulnerable library or software on that system, right? I used to work at Tenable, so I understand all those conditions very, very well.
You know, and that's just where that human element and the testing comes back in. It looks great, but let's make sure.
Agreed. Now, I really am excited to talk about the different types of penetration tests, also the different goals and outcomes that you should have for pen tests, because I believe this has really greatly evolved, like from way back in the day where it was a red team assessment, you give us your external IP, and our goal is to break in, right? And that's what pen testing was. I love the evolution of it, because I think there's so many different areas that we can test as part of a penetration test. The first area that I had was really response and processes, right? I mean, it's great if I can break into a system, but for me as the pen tester, not so great for the organization, right? And maybe I escalate and I get data, and that's a finding. But it can also test those the response and the processes that did you detect that someone got in, right? Do you find that some of your tests you're doing more testing the processes and the response more so than the actual vulnerabilities and exposures?
Yeah, absolutely. I mean, kind of what you're describing is what some people call red-blue teaming, where the blue team is kind of people responsible for identifying that there is an attack and how do they respond and react. And what we're seeing from a lot of organizations these days is more purple teaming.
Yes, exactly.
And the
analogy
analogy I would use is, you run a football play and I burn you on a screen, you say, well, I was looking for a deep pass. Well, if I tell you I'm going to run a screen and you can't defend it, I know a lot more now, don't I?
Yes.
And we're seeing more organizations declaring, hey, we're going to do some SQL testing. Let's see how, number one, you can, identify what we're doing, and number two, how you do react.
Right. That's so important, to testing the entire process, not just whether or not a control is in place or not.
Right.
Which is great. And, I think for me, I've kind of broken out with purple teaming, right? I think you need make sure you incorporate all those different groups, right? So you have maybe the red team, maybe they're internal or external. You've got the security team, and then you've got the sysadmins, and then you've got the network admin. And that's all part of your blue team, so I like to make sure organizations test all those different components, not just can the SOC detect that something happened.
Right.
How does that escalate down to the sysadmin, who may also need to rely on the network admin or the cloud admin to go deploy new infrastructure, right? So your blue team is really everyone in your organization.
Yeah, response time is very important. I mean,
Yeah.
to your point, if this is a process that takes weeks, I mean, time is your enemy. I mean, if you really have somebody that, comes into your environment, to be able to stop it as soon as possible is important. So having a good chain and understanding response and how people react is very important.
Because someone's always going to be able to get in, right? I mean, let's be frank. There's always going to be, like you mentioned the user before.
Yeah.
Some user's going to click something, right?
Yeah.
But if you can spot that as quickly as possible, I think that's really what security comes down to, right? Is as quickly as possible response.
Yeah, exactly. I mean, I think we're pretty much in our industry now where people realize that we're not going to be able to stop everything. And the user is the big issue. I mean, I heard this anecdotally. Maybe you know the source for it, but I heard roughly 75% of people will fall to a modern phishing attack where they're doing highly trained programs. They can't get it below 15 or 20%.
Yeah.
And, so you're always going to have people clicking on links, giving up creds to a good fish on a social. Someone calls you up, says, hey, I need XYZ. Right. So there's always going to be exposures in organizations.
And I also think another aspect of pen testing is you test the process and the response, right? And you may test the vulnerabilities and exposures, but you also want to test the tools. You put these tools in place. You've got a SIM, you've got some endpoint protection. How do you know they're really working, right? And that's, I think, a different type of test than just trying to find vulnerabilities and exploiting them, or testing the process is, did my security tool discover the alert? Did it block when it was supposed to block?
Yeah.
Like, did it do all the things it was supposed to do? And that's a pen test gives you a great way to test that.
Yeah, there's a lot of different approaches to pen testing, as you know. I mean, I could drop an agent on a system, come in with PowerShell, and look like very normal traffic, and I might be very hard to detect. There's other things that can do that are a little more noisy. And, depending on what I'm doing really kind of affects my detectability per se. We run a testing suite of a lot of the endpoint agents and our own testing, to see how effective our exploits are in bypassing them. And it's the same thing organizations are doing as well. They want to replicate a lot of what we do in building our product in their organizations, just to see how effective some of those measures are.
And the response to that sometimes is you just need to configure your security tool differently or better. And sometimes the response is, well, that's never going to detect that. I need to rely on something else to detect it, right?
Yeah.
And so if you do both those things, you're in much better shape if this is an iterative process.
Yeah.
How often, Steve, do you think people should do the human-based pen test?
It really depends on your objectives in your organization, what you're doing. What we find is most of the pen testing teams that are employed within the organizations, they're doing it on a continuous basis. They're rolling out new apps. You definitely need to pen test them before you roll them out, especially web apps. I mean, if you're putting web apps out without doing a pretty extensive test of them first, that's just asking for trouble.
No matter how you automate that, develop our internal application, you can automate all the tests you want until the user hits it. They're just going to come up, whether it's a user or whether it's a pen tester, they just come up with scenarios that are very difficult to account for as a developer.
Yeah, exactly. And it also just helps give you some of that assurance that, hey, it does look like, we're in pretty decent shape. You're never obviously totally secure.
Right.
Infrastructure, any new infrastructure getting rolled out, et cetera, should be tested. We see a lot of audit teams coming back with the vuln programs. One of the major bank customers we have, the guy who runs audit for him, he's one of our biggest customers within the bank. He has multiple testers, and what they're doing is going back and making sure that the remediations and stuff that was supposed to be corrected and found was actually corrected.
Right.
So how often, I think, really comes back to what are you doing within your programs, et cetera.
And how mature your program is, right? I think not like early on the maturity curve, you're testing just to kind of get like a feel for what you have, what might be most vulnerable, right, to help prioritize. Then as you mature, like you said, Steve, as you build out new security infrastructure and applying security to it, I want to test that after it's been built, right?
Yeah.
Early tests may go, this is what you need to build, right?
Yeah.
But you also need to test after you've built that to say, okay, does it really work?
And you're making a great point on that early testing. There are some organizations that shouldn't pen test.
Yeah, they should do a vuln scan first,
Exactly.
right? Yeah.
You know, until you do some of the basic security things, you don't need a pen test to tell you, hey, you got this whole world of broke things.
Right.
You know, go put in some of the basic things first, you know. But as you get more security mature, it does kick in. And I do think also it's important occasionally to get that third party to take a look as well. Most organizations, you know, that have some very highly qualified people, including in our federal space as well, they're leveraging third parties to come in and just be a fresh set of eyes, you know,
Absolutely.
take a look.
Completely agree. Well, Steve, thank you so much.
Well, thank you. It's been a pleasure.
Welcome to Security Weekly. We're broadcasting live from Black Hat 2019. We're in our suite at Mandalay Bay, and joining me for this interview is Ian McShane, Vice President of Product Marketing at Endgame. Welcome, Ian.
Hey, man. Thanks for having me again.
Always a pleasure. I like I said to you when you walked up here, you can just talk. I don't even care what you say. I just want to hear the accent.
All right. Well, I can ramble as long as you like. It's all good.
Awesome. You're making some interesting announcements this week around Mac and Linux support. Give us a quick update, and then I have some interesting questions for you as we dig in. What's going? Yeah. Well, what's going on with
Cool.
Mac
I
and
mean,
Linux?
so we've just got a release coming out next week, and what we've been focusing on really for the last 18 months is really bringing equality to all operating systems. Right? If you think about where security's come from, everyone focuses on Windows,
yeah.
and that's fine, right? That's the biggest threat landscape. But Mac and Linux have kind of been forgotten about, and there's been very little in the way of guidance for organizations that use Macs and Linux. And by the way, that's pretty much every organization.
Yeah.
Right? I mean, you use a Mac yourself.
I use a Mac. Paul uses his Linux machine.
Right,
so,
exactly.
Yeah.
So focusing on Windows as an organization really leaves you with this big visibility gap. So what we've been trying to do at Endgame, starting with our release in January 2018, was really kind of level that playing field. So we shipped our machine learning model for macOS files, and now we're adding this capability to do what we call reflex, which is rule creation at the endpoint, so you can start to define what's acceptable and unacceptable, not just on Windows, but on macOS and Linux as well.
Got it. Because if you think about your solution kind of spans multiple pieces, right? You've got the kind of the prevention component, you got detection and response, et cetera. And as a Mac user, right, I go out and I look for antivirus for the Mac. Where does everybody go, right? There's like one solution that's kind of
I'm not
there.
going to name drop them.
No, I'm not either, to be fair to you. But you don't have many choices, right? And then you think about detection and response capabilities on the Mac, and you're like, what actually works there? How would I do that? So when you think about all the protections now that are in the Endgame Windows capability are now fully available on Mac and Linux with this release?
Almost. I mean, let me be clear. Right, the threat model in Mac OS and Linux is different to Windows, so we're not doing exactly the same thing.
Right.
But the real key concept is for investigations, for visibility, for containment. That's the big one.
Right.
You can do that across any platform. One-click containment. If you're starting to investigate an alert or an incident, doesn't matter if it's Windows, doesn't matter if it's Mac OS or Linux. Click a button, contain that endpoint, and actually do the investigation yourself. Whereas if you don't have that integration into your platform, maybe you're using something like Jamf to manage your Macs.
Right.
So you're having to pivot into another system, do some investigation work there, and then match up with the other traffic that maybe you're seeing. And I mean, we've got a great demo, and I don't mean to hawk our demo station here at Black Hat, but really you should come and see our demo where we're showing some of the really interesting work that the attackers are doing on Mac OS. We've got a demo that shows some of the APT groups that are using Mac OS as an attack platform.
Oh, it's interesting because we always think about Windows being the attack platform, right? And so everybody goes after Windows first, but you also all the tools are on Windows now. What are some of the nuances and differences when you had to build the solution? You got PowerShell on Windows. What changes when you move to Mac in Linux-based systems?
Yeah, so one of the key things we did at Endgame is that we didn't want to trust Windows at all. So we hook into the kernel to get the information, to get the data that we use to create events, to create our investigation database. when it comes to Linux, you don't really want to be mucking around with the kernel too much. And
You don't want to deal with glibc? Come on.
seriously, right? So what we wanted to make sure we could do was continue to provide strongest, investigation data on Linux that wasn't being hampered by, attaching itself to a kernel and stopping the security administrator from securing his devices.
Right.
So that was one of the key differentiating decisions we made versus the rest of the competition, is that on Linux we wanted to stay out of the kernel, whereas on Windows we wanted to make sure that we were, using that kernel to do things like, isolating at the network level rather than relying on the Windows firewall, because anyone can get past that.
Right. So where do you run? And you're not at the kernel, so you created kind of a shim in between
We're
the
running
kernel.
in user space on
user
Linux.
space.
Yeah, exactly.
Okay.
And again, right, it's not the same ecosystem, right? It's not a file-based threat landscape. With a good Linux system, and it's been a while since I've been a sysadmin, so you'd have to excuse my naivety, but Linux protection should be about application control, right? Just identifying what processes and what applications can and are trusted to run on that device, and then nothing else.
Right.
Right.
And so you don't need you can do it from the kernel, but you decide to stay away from the kernel and do it
It's just
in the user
problematic,
space.
right?
Yeah.
We got a lot of feedback from our customers when we were talking to them about what they needed, and one of the things they said was that the solutions they have right now can't be upgraded because they either are too far behind on the kernel they've got, or they can't move the kernel because there's no agent that supports it.
Yeah.
Like some vendors take 3 to 6 months to support a new kernel version, and this comes back to the whole equality across the operating systems.
Right.
It's forever Mac OS and Linux has been a tick box. Yeah, of course we've got it in an RFP. Yeah, we support this, we support this. But now we're really driving that home, that you need this full visibility to actually have a decent security practice.
Yeah, and Mac is just a variation of Linux for you, so it's
that's similar. We do a bit more in the kernel on the Mac.
Okay.
Also in user space, but we do some stuff in the kernel.
in the kernel as well,
Yeah.
just so you make sure that the data you're getting
it's legit, right?
Yeah, right. So all the prevention capabilities, all detection and response. You guys also do some really interesting stuff with files and file monitoring, like looking for malicious macros and stuff in file. All that's also supported in the
that's
in the
right.
Mac
That's all
and
coming
Linux
to that.
and
It's coming through Office files. Yeah. The malicious, weaponized documents. I love to rail on people like Proofpoint and Microsoft really for not solving this, spam
Right.
epidemic that's using weaponized documents. So we had to fix it on the endpoint, but we put a lot of work and effort into our ML model for that.
That's awesome, because it was a really interesting feature in Windows, and so to be able to port some of that over into these other two operating systems, I think is pretty cool.
Yeah.
Artemis. Does Artemis work across these platforms as well?
Indeed, it does. So
It
Artemis
does.
is our chatbot, right? Our
Yeah.
AI chatbot, which a lot of organizations find really helpful when they're onboarding with the product.
Right.
Because you can ask it plain English questions. Have I seen this file?
Yeah.
Have I seen this IP address? And again, we don't care what the operating system is. We're going to look at every available piece of data that we have for you, and hopefully, collecting data from Linux, from your Mac OS. Artemis just sees a bunch of endpoints and says, here's what I've seen, here's what I know.
That's great. So, obviously, you had to make sure you normalized all your data across the different OSs, so when you ask Artemis a question, it knows how to go get the data and return it in a consistent way.
Exactly.
That was obviously part of the engineering fun behind the scenes.
Yeah,
But
some of the response actions are slightly different, but that's how it works across multiple platforms. But just wanted to have this consistent user experience. That was the big thing.
Right, and I think that's important, right? As we think about solutions out there, you don't want 3 different solutions to do your endpoint security. Just like people don't want 3 different systems to do their patching, for example, right?
Yeah.
And when you have a mixed environment where you have Windows, Mac, and Linux in the environment, that's what a lot of people have to fall to is 2 or 3 different solutions to manage these environments. That just adds to the complexity.
And then you've got no single source of truth, so you start to question which, if the data looks different, which one's right? Who do I trust?
Yeah. And so by consolidating it all together, making the agent cross-platform, now you get all that great centralization, normalization across the entire platform. I think that's awesome. So people here at Black Hat, you want booth number. Where should they go to check out the demo of the new capabilities?
It's booth 1253. It's in the Shoreline. It's either Oceanside or Shoreline. I think it's Shoreline. Whatever.
I haven't been down there
Stupid
yet.
names,
I have no idea.
But you can't miss us. We've got one of the biggest booths there. It's 2 stories tall. If you stand there long enough, you'll see a 25-foot picture of my face on the video wall. So you can't really miss us, but you should totally come down and check out the demos. We've got some really interesting research going on.
Awesome. And if you're not at Black Hat, where should they go to check out the new capabilities?
You should definitely go to endgame.com/demo, and we can set you up with a demo, and you can walk through and see how you can benefit from all these great advancements yourself.
Awesome. Anything else? Well, I got you here.
No, it's great to be here as always.
It's always fun to have you.
Hospitality.
Yeah, we love it. Thank you so much,
Thanks
Ian.
so much, man.
All right, everybody. We'll see you on the other side. Welcome to Security Weekly. I am your host, Matt Alderman. We are recording live from Black Hat 2019. We're in our suite at Mandalay Bay, and I am joined by Peter Smith, the founder and CEO of Edgewise.
That's right. Thanks for having me, Matt.
Thanks for joining us. Now, we've interviewed your folks a couple times on the show. Really love your technology. But we're going to talk about an interesting use case of your technology today, really when it comes to administrative tools. So let's frame up the problem of admin tools, PowerShell, Bash, etc. And where are some of the challenges that you guys see? And then we'll talk about how Edgewise can help solve aspects of those challenges.
Yeah, administrative tools pose a very significant challenge. They tend to have access very broadly because they can do multiple differentiated things. So think about, for instance, a MS SQL database administrative tool. It can connect to a staging system, a dev system. It can connect to a bunch of other things. And what that really represents is administrative tools represent high potential for abuse by attackers, as opposed to fixed function business applications where they really just do one thing. Every time you run Microsoft, Dynamics, it connects to the same database. Doesn't matter how you run it, it just does one thing. Whereas that MS SQL admin tool can do a variety of things. So as an attacker, you want to get your hands on that because you can abuse the access it has.
Yeah, and if we think about where application development's going, right? This concept of DevOps, right? You have a lot of these tools being used by the operations team to deploy software into production or from the development team, et cetera. So, right? So we see a proliferation of some of these administrative type tools deploying code into various test staging production environments also.
Yeah, that's the exact reason why Locker Goga is a good example. Which was the malware that was used in the Norse Hydro attack. That was really intended to go straight to Active Directory because, as you pointed out, as far as distribution is concerned, it centralizes all of the access. Everything accesses Active Directory, and Active Directory generally has access to everything. SSM would be a great example, Puppet, Chef, Ansible, SaltStack, so on and so forth. All of these tools require the access, and therefore it represents great potential for lateral movement using that access.
Right. So some would say, well, I have an endpoint detection response system, or I have my firewalls in place. I have these other tools. Why are they not as effective in addressing aspects of this challenge?
Yeah, administrative tools are pretty complicated because the difference between what an administrator does and what an attacker does from just a sort of key indicators, they look very similar. How do you disambiguate a PowerShell script that is connecting into an Active Directory domain controller versus the same type of script that's used by an attacker for the same purposes? And a lot of the approaches used today, you would say security groups or next-gen firewalls or even the EDR platforms, they really just don't have the ability to control at the right level. So as an example, Edgewise, we've got a very different approach. You can apply differentiated policy on a per script basis. So for instance, you might have an individual Python script that only needs access to one system. You can apply policy to that individual Python script to give it only the access it requires. Meanwhile, another Python script running right next to it on the exact same system does not have the access. You can do that for PowerShell, Python, even individual Java jars. So it's a very different way of managing access at the script level, at the software level, instead of sort of at the system or IP address level.
Right. So instead of trying to do it at the network layer or at the holistic endpoint layer, you're doing it, I would say, more at the application layer, right?
That's a great way of putting it. Yeah, I could not agree more. It's the software itself that needs the access, therefore give the access to the software.
And this is what makes you guys a little interesting in what you do from a microsegmentation protection perspective, right? It's that that's granular software application control capabilities that you allow certain apps to talk to other apps, and that's the only thing they can do, right? Which enforces kind of a whitelisting approach, right? When you think about it, is I have said this can talk to this and don't let anything else happen. Where it's not as easy to do that because at the network and the endpoint layer, it requires you to understand behavior across those diverse environments, and that's really, really tough, I think, for most organizations to be able to do, or a vendor in that case.
Let's take an example. And I'm always reticent to invoke the most recent to breach, so I'm not going to actually say the name, but there was a recent breach where access to the 169.254, 169.254 port 80, which is the AWS metadata service, was required for the Amazon SSM agent. And really, when you allow access to that service through a security group, what you're allowing access to is anything running on that server now has access to the AWS metadata services group. And I think people just don't really think in those terms that when they assign an ACL to an address, what they're actually doing is assigning that ACL to anything that runs on that system, and therefore it can access it. And our differentiated approach is that you could say that only the Amazon SSM agent is allowed to talk to the AWS metadata service. Nothing else has that access. Nothing else besides that one Java jar is able to access the S3 bucket.
But wasn't the promise of next-gen firewall to be able to do this at the application layer? I'm just, I'm being a little facetious, but that was the point, right? If I know layer 7 traffic and I know the application that's coming through the firewall, I ought to be able to control that at the application layer.
That's right. That's the promise. That's why they call it application identity. But the reality is that's layer 7 protocol identity. So a great example, and one that we often use, is the MySQL jackpot exploit, which was using user-defined functions in standard MS SQL queries to remotely load a plugin into a MySQL database and exploit it. And the firewalls, we've gone through all of the firewalls to test it, and not a single one of them can actually detect it. They accurately detect that it's MySQL protocol, but that's not the software. That has nothing to do with the software. It can't differentiate basic telnet administrative tool from the actual jar that should be connecting from the MySQL jackpot exploit. And that really just sort of emphasizes what the deficiency of protocol inspection. Not to mention which, I think it's worth pointing out that nowadays, everything talks over HTTP or HTTPS, not to mention TLS 1.5, which is going to make introspection of those communications even more difficult. So I think deep packet inspection in general sort of misses the mark on actually controlling what is communicating. It's certainly better than no security at all, but I truly believe that application identity at the software layer is the future.
Yeah, and I always equate this to, as we think about digital transformation, we're going to abstract away the network. We're going to abstract away the endpoint. What's left? It's the application and the people that are accessing the application, right?
I love it.
And so I've always been this big proponent of app user data. Those are the 3 types of security controls that transcend digital transformation. How does that triad become secured better, right? I'm a big fan of identity and the expansion of identity into the application side with service accounts, et cetera. I think better controls around applications, what applications can communicate to, and then obviously at the end of the day, it's all about data protection because that's what everybody's after. They're after the credit card data, the PII, whatever it is. And so what you've done is you've addressed a big portion of the application layer, probably a little bit into the identity, but very important pieces is part of what you call zero trust
identity.
Microsegmentation.
There's a lot there. So as far as identity is concerned, we really view identity as exactly what you said: the identity of the user, the identity of the device, the identity of the software. And as far as this concept of digital transformation, if you peel everything away and you say, what is access really? What is it? There's 2 things that talk to each other. Software talks to software. Software is controlled by users, whether that's a service account or a person hands that keyboard. And so from my vantage point, assigning policy to software is the key because to your point, it abstracts away all of the how. So a good example of addresses, ports, and protocols, traditional firewalling, that's how things communicate. That says nothing of what is communicating. What is software talking to software controlled by users? That is the world of Edgewise. That is the world of zero trust identity.
And that's the challenge I think everybody's going to have to continue to try to solve in this new world. So I'm listening to this. Let's talk just quickly about deployment. How does this thing, how does it deploy? What do you need to do to set up Edgewise?
Coincidentally, we'll use SSM, Active Directory, Puppet Chef, Ansible, SaltStack, whatever configuration management or broad systems management capabilities you use. We'll use those to actually deploy our LSM module and WFP module into your Linux and Windows environments. Now, once we do that, we analyze the environment, we collect all of the identity properties of the communicating software, build this directed graph. It's a visual graph representation of how all things communicate. One of the main differentiators of what we do is that we can actually see through through load balancers. So load balancers are pervasive, right? And they stop you from seeing end-to-end communication. We see through that, so you get a perfect topological map of your environment. Then the ML system over approximately 72 hours builds the policy set and gives you one-click automation of deploying those policies into a simulated block state. Once you're confident in those policies, you can switch them from simulated to actually enforced.
Wow.
Yeah, so the irony here is that we'll use this broad access from Active Directory and otherwise to get the deployment in place, and then we make sure we secure it so that only the SSM agent can talk to the appropriate Amazon endpoints or
Right.
in the case of Active Directory, LSAS to LSAS, so on and so forth.
Yeah, I got it. So first, get that visibility. Where is everything at? Do a little modeling of understanding kind of what that behavior looks like, which is tough. Then set of policies to simulate and then eventually block anything that's abnormal or malicious.
Perfect.
Awesome. If people want to get more data or more information, where should they go?
Edgewise.net. It's the place to be.
Awesome. Peter, it was an awesome interview.
Thank you very
much. And with that, we'll take a break and see you soon.